Okay, we have graphed linear equations, we've solved systems of linear equations. We're going to take a shift. We're still going to need that basic background of graphing equations, but we're actually going to start graphing linear inequalities. So inequalities that have two variables. So this first thing that I want us to actually look at is a couple of vocabulary terms just to make ourselves a little familiar with what we're discussing. So the first one is linear inequality. And this is actually what a graph of a linear inequality will look like. It doesn't have one specific solution or like systems do, and it's not just a line. Inequalities, remember, thinking back, are greater than, less than, greater than or equal to, less than or equal to. And so once you have a boundary line like this one, you've got to determine, am I going to have values greater than or above that line, or will I have values below that line? So with linear inequalities, it's not just enough to actually draw the line, but you're going to have to shade a region. Now, that leads us into what the solution of an inequality is. It's any ordered pair that makes the inequality true that will be in the region. Now, notice that this line is a solid line, and in this other vocabulary term, we had a dotted line. Okay, that's one other thing that you have to take into account whenever you are dealing with graphs of linear inequalities. Remember when we had open and closed dots on our number line, an open dot was the greater than symbol or the less than symbol because that was our starting point, but that we couldn't use that point. And the same thing is here. This is our boundary line. Think about, houses have the boundary lines for your property. This is our boundary line, but we can't include this line. We can't include the points on this line because we're just dealing with greater than. The same thing goes for this problem here. This is a solid line. This is still our boundary line, but because we're also talking about equal to here, that would be your closed dot when we were dealing with just number lines. So in the coordinate plane, that means our boundary line is solid, which means we will include the points on this boundary line. So you're going to graph these just like you would an equation. The only extra things you have to do is decide, am I going to have a solid line or a dotted line, and where am I going to shade? Will I shade above the line or will I shade below the line? So those are some of the examples that we're going to look at. Now, before we get into graphing, we want to talk about, can you actually identify solutions of a linear inequality? And this is very simple. This is just substituting in values. Okay, the ordered pair that you've been given here is 1, 2. The inequality is y greater than x minus 3. Well, to determine if this is a solution, plug the 1 in for x, because that's the x part of your coordinate, and plug the 2 in for y. So this is what this is going to look like. Once you plug in 2 for the y and 1 for the x, this is what your inequality looks like. And then just simplify. 1 minus 3 is negative 2. So then you just ask yourself a simple question. Is 2 greater than negative 2? And that's why we have this check mark here. Yes, it is. So that means that 1, 2 is a solution. Is it the only solution? And that's no, it's not the only solution. That just happens to be a solution or one solution for that inequality. So let's look at this example. The same inequality, but this time they're going to give us negative 3, negative 7. So negative 3 goes in place of your x. Negative 7 goes in place of your y. Always be very careful with your negative signs. So negative 7 went in place of our y, and negative 3 went in place of the x. And then simplify. Negative 3 minus 3. Well, if you're down 3 and you go down 3 more, you're down 6. So then ask yourself, is negative 7 larger than or greater than negative 6? And you're dealing with negatives, so you kind of have to think a little bit backwards here, but negative 7 is not greater than negative 6. It's actually smaller than that. So this is why we have an x here. That is not a true statement. Therefore, this is not a solution. So it's that simple, being able to determine, do you have a solution or do you not have a solution? So now it's your turn. I want you to take this inequality. Now this is less than or equal to. So the difference in this is that if this side winds up being the same as this side, then that's a true statement because we can have them being equal to each other in this problem. So you've got to just be able, when you read the inequality to yourself, just ask yourself, true or false? Is that a true statement? So plug in 3 and 6 into your inequality. Here are some answer choices, just yes or no. That's that simple. Is it a solution or not? Pause the video if you need to. Take a minute to simplify that. Hopefully you've done that. So your correct answer is yes, it is a solution. And here is the way to simplify that. 3 goes in for x, 6 in for y. 6 is less than or equal to 6. Is that true? And it is. Now, keep in mind that if that equal to sign wasn't there, this would be a no, because 6 is not less than 6. But because there is an equal to sign, this is true. 6 is less than or equal to 6.
In this problem, you will graph an inequality in 2 variables. What is the graph of the inequality y is greater than x minus 2? First, graph the boundary line y equals x minus 2. Why does the equation y equals x minus 2 represent the boundary line? For any value of x, the corresponding value of y is the boundary between values of y that are greater than x minus 2 and values of y that are less than x minus 2. Since the inequality symbol is greater than, the points on the boundary line are not solutions. So use a dashed line to indicate that the points are not included in the solution. To determine which side of the boundary line to shade, test a point that is not on the line. For example, test the point 0, 0. Write the original inequality. Substitute the point 0, 0 for the point x, y. Simplify. The point 0, 0 is a solution. Because the point 0, 0 is a solution of the inequality, so are all the points on the same side of the boundary line as 0, 0. So shade the area above the boundary line. Now it's your turn.
All right, so you have the inequality y less than or equal to 1/2 x plus 1. So you got a lot to think about here. First of all, you've got to graph this. So plot your y-intercept and then use your slope as rise over run. Okay, so my y-intercept is 1, my slope is 1/2. So graph this as if it were an equation, but before you draw your line, you've got to determine, is this going to be dotted or dashed, or is it going to be a solid line? So you got to determine, are we going to include the boundary line or not? And then once you've done that, then you need to find a point, and if 0, 0 is available, that's an excellent point to use. If it's not available, then pick any other random point and decide, plug it in and see if it works. Now, in the last example, the point 0, 0 worked, so we shaded on that side. But if 0, 0 didn't work, then you couldn't shade on that side. You would actually have to go to the other side of the boundary line and shade. So different things to think about. Here are some answer choices of what your graph should look like. So take a minute, pause the video, go through, make sure you can graph this one and match it with one of those choices. Now, the correct answer is D. That is going to be your graph, it is a solid line because of the inequality, and it is y less than or equal to. So if you plug in 0, 0, it works, and so it's everything below that line. Now, we're going to talk about real quickly just graphing some inequalities that are real simple, but ones that are forgotten or a lot of people have trouble with. X is greater than negative 1. When we talked about x equal to a number, back when we were first graphing, we talked about how there's not a y, which means there's not a y-intercept. So this line cannot go through the y-axis. Well, the y-axis, remember, is the vertical line. So what types of lines will never intersect the vertical line? And that would be another vertical line. They have to be parallel. The same goes for inequalities. When you graph x equals negative 1, that would have been a vertical line going through negative 1 on the x-axis. Notice that it doesn't have a y-intercept because there's not a y in the equation. Now it is greater than. There's not an equal to there, so that's why it is a dashed line. And then you can test the point 0, 0 to see which side to shade on. So if you put 0 in for x, 0 is greater than negative 1, so we're going to shade on this side. When it's just an x value here and not a y, it's pretty easy to determine the side to shade on. X greater than negative 1, if you look at your x-axis, those are all of these points in this direction. So we are shading to the right of that line. Now if we look at one where y is greater than or equal to 2, there's not an x here. That means there will not be an x-intercept. The x-axis is the horizontal line, and the only line that you can draw that will never intersect a horizontal line is another horizontal line. So y equals something. Those were our horizontal lines, and they're the same here. If I were to graph y equals 2, that would have been a horizontal line through the point 2 on the y-axis. Now it is a solid line because we have greater than or equal to, so we are including our boundary line. So we do have a solid line, and then we can test the point 0, 0, and you can see for this example, when I put 0 in place of y, 0 is not bigger than 2. It's not even equal to 2. So 0, 0 does not work. This point does not work. That's why we cannot shade below the line. So we have to shade above the line, and that only makes sense since you want y greater than 2. All of these values on the y-axis are greater than 2 in this direction, so that's why we would shade above our line. So I want you, this is your turn, you have to think about what the x and y, those really small equations, what they looked like, and then manipulate those into our inequalities. So here's your inequality, x less than negative 5. Think about what this would have looked like if this were x equal to negative 5. That's for how you draw your boundary line. Here are two answer choices. So hopefully looking at the choices there, that makes it a little bit easier to figure out. But there's your answer choices. Take a minute to graph that. All right, here is your correct answer. It is B. Okay, the problem with A is that this is negative 5, but on the y-axis. It's on the wrong axis. We want negative 5 on the x-axis. It does not have a y-intercept, so it must be vertical. And we want everything less than negative 5, so it's going to go here to the left.